All right, guys, today we're going to talk about all the properties of exponents. Sorry about that. There's several of them, and you know what I'm going to do tomorrow. I'm going to give you gestures for them, but you need to just know them. And the next slide has them all. This slide right here would be worth, getting your phone out, taking a picture of it or whatever. This is all the properties of exponents that you would have to know. And let's just go through them real quick. First one is product of powers, which says if you multiply the same base, all you do is add the exponents. And that's it. So like if I have 5 to the third times 5 to the -1 power, you just add them up, add your exponents, you get 5 squared is 25. Now notice when you multiply, all you do is add the exponents. Some people make a mistake and multiply the numbers and add the exponents. All you do is add the exponents. If you have a power of a power, that's when you multiply your exponents. If you have an exponent inside of parentheses and one outside, you multiply them together. Here's an example, 3 cubed squared, multiply your exponents, and there you go. Power of a product. If you have an exponent outside of parentheses, it applies to everything inside the parentheses, a to the m, b to the m. Here's an example right here. Notice that's multiplication inside, that's why it's called power of a product. If it's addition inside, it's a little bit different story, but we'll work on that later. Negative exponent is just as reciprocal. It flips whatever number has the negative exponent on it. For example, if you have 7 to the -2, it becomes 1 over 7 squared. A zero exponent, anything to the 0 power is 1. And I mean anything, even -89 to the 0 power is 1. X to the 0 power is 1. And I'll show you why in class tomorrow. Quotient of powers. When you divide, go back up here a minute. When you multiply the same base, you added the exponents. So it makes sense that when you divide the same base, you subtract the exponents. And that's what's going to happen right there. The power of a quotient, if you have a fraction raised to a power, you have to raise the numerator to the power and the denominator to the power. And you can see the example right there. 4/7 squared, same thing as 4 squared over 7 squared. Raise both to the power. All right, let's just do some problems now with exponent rules in them. And this is what you're going to see tomorrow, just a whole bunch of exponent problems. So the first one right here, I have an exponent outside the parentheses. Remember, that goes for everything inside if it's a product. So I'm going to do -4 squared. And I'm going to do 2 to the 5th squared. I'm going to square each one of those. If you square -4, you get 16. If you square 2 to the 5th, you get 2 to the 10th. Because you multiply the exponents again right there. 2 to the 10th is huge. It's like 1,024, and if you do 16 times 1,024, you get 16,384, and everybody knows that, I'm sure. So that's all you do for that one. The next one I'm going to do the inside part first. You have a couple of choices sometimes. Order of operations says that you work inside your parentheses before you go outside. So if I do that, I'm going to subtract my exponents inside. That would give me 1 over 11 cubed, and I have this -1 outside. That -1 flips, remember -1 power flips it, so it gives me 11 cubed over 1, which is just 11 cubed. That's all you gotta do on that one. And the next one is just straight up multiplications. You would just multiply the -8s, add the exponents. 1 plus 3 is 4. You do -8 to the 4th power, and that's all you have to do on that one. I'm checking my calculator to see what -8 to the 4th is real quick, and it's 4,096. That -8 should have been in parentheses right here. So the negative sign gets the 4 also. More or less, more the same. Evaluate these. The first one up is a straight up multiplication. When you multiply the same base, all you do is add the exponents. All I'm going to do is I'm going to add -4 plus 6 plus 7. Now we get, -4 plus 6 is 2, plus 7 is b to the 9th power. And that's all there is to it on that one. The second one here, it's got a fraction bar, so we're going to divide. 16 divided by 2 is 8. There's nothing to do with the m, it's just m to the 4th. Now, if you notice on the numerator and denominator, I have n to the -5 both places. They cancel, or you could also do the rule and subtract. And if you do -5 minus -5, you get 0, which is n to the 0, which is 1, so the ones are just gone, the n's are just gone, so there's no 2 answers on that slide. These are really quick problems. The only issue is you have to know which rule to use when and keep them straight. That's the hardest thing, is just keeping the rules straight, when to use what. All right, 3 more and we're done here. First one has a fraction, and I'm gonna, you can go lots of ways here. I'm gonna go ahead and multiply the -3, because when you raise a power to a power, you multiply, which would give me r to the 6th in my numerator. s to the negative 9 in my denominator. And what I'm going to do now, because it's a negative exponent, it's going to flip it the s to the top. The r is fine. R6, S9. That's all there is to it. The second one has same deal. It has a 2 right here. So I'm going to go ahead and raise all those powers to a power, make it x negative 6, y to the 6th, x to the 5th, y to the 6th. What I always do is this. I always look for, because there's division, I'm always looking for the biggest exponent. Well, my x's and the biggest one's on the bottom, which means my x is going to stay in my denominator. And I'm just going to subtract 5 minus the negative 6. 5 minus negative 6 is actually 11, so I'm going to have x to the 11th power in my denominator. And in my numerator, the 6 cancel completely, so I just 1. So just 1 over x to the 11th power there. And the last one of the day, finally. So this is straight up multiplication. And don't forget, multiplication, you add exponents. So first of all, I'm going to bring down to 7. 7 times 1 is 7. Look at your x's. 2 plus negative 4 is negative 2. Look at your y's. 5 plus negative 1 is 4. And because the x has a negative 2 exponent on it, that means you have to flip it. So it's going to the denominator, 7y over x squared. That's all you got to do on that one. So again, not terribly tough. The problems are very short to work out. Your only issue is going to be making sure you're using the right power at the right time, right power rule, or right exponent rule at the right time. Once you get that down, you should have no issue. And like I said, I'll give you some gestures tomorrow, which I know you're excited about, and we'll see you then.